All right, good morning, sixth graders. Today I'm going to go through and read the article for Activity 5, which is Conservation of Energy. So again, this is Activity 5, Conservation of Energy. These are the performance standards that we're working towards. We will have an assessment in Activity 6 starting tomorrow, where we'll show that we're able to do some of these things. Our key vocabulary for this unit or for this activity is energy conservation. We've already looked at energy efficiency, energy transfer, and energy transformation in the earlier activities. And the other new term is the law of conservation of energy. In the introduction, so we're going to read the introduction and look for key ideas. So you want to fill out your Google slide presentation for writing down key ideas while we read through the introduction. You can always pause the video so that you can write things as you go back and forth. So this is the introduction. You have been exploring different types of energy transformations, from gravitational potential energy to kinetic energy of motion, and vice versa, as well as from kinetic energy of motion to thermal energy. What do all these transformations have in common? Scientists have observed that all energy transfers follow certain principles. In this activity, you will learn about one of these principles and you will begin applying it to your home energy efficiency plan. A home energy efficiency plan is the student sheet 1.2 that you should be working on as a rough draft. So how can you use the law of conservation of energy to describe energy transformations? This is the guiding question. So you want to take an idea and a guess right now, and then we'll answer this question again at the end, where then you'll also fill out the exit ticket with the same question. How can you use the law of conservation of energy to describe an energy transformation? So in the picture we have, when wood is burned, chemical energy in the wood is transformed into thermal energy and light, or light energy. We have a scientific law. A scientific law is a general statement about the physical world that is based on empirical observations and evidence. In other words, that there is lots and lots and lots of things that we have seen and done, different experiments we have done, and we always get similar or the same results. A scientific law is distinguished or is different from a scientific theory in that it has no opposing evidence discrediting its assertion, and it has never been known to be violated. In other words, with a scientific law, there is nothing that says that it isn't true, and there's no evidence or anything that has happened to say that it is not true. So a scientific law is different from a scientific theory. A scientific theory can have evidence that goes against it. A scientific law does not. Our driving question. So again, as we're going through this unit, we had the one driving question about why does my cell phone break when I'm standing versus when I am sitting? Here we have another one. What are the similarities and differences among different types of energy, or these different types of energy, between kinetic energy and potential energy? What are the similarities and differences between gravitational potential energy and thermal energy and light energy? All right, so we're going to complete the reading activity, the 3-level reading guide. This is student sheet 5-1. This is a separate document in your classwork, and you're going to answer these 3 questions when you are done with the reading. So after you're done with all of the slides, then you're going to do this activity. You're putting an X next to one of the statements, A, B, or C. For number 2, you're marking all of the statements that are true. My hint is that there is more than one true statement. And then you're putting an X if you agree or disagree with the statement, and then saying why you agree or disagree. You could also write the word agree or disagree and then explain in a sentence why you agree or disagree. You will have to open up a text box in order to type things. So you'll have to insert a text box in order to answer and edit this page in Classroom. All right, so here is the reading. So this is the energy in action. You want to make sure that you write down at least 2 main ideas or 2 facts from each section. So the first section is energy transfers and transformations. It says, from our everyday experiences, energy seems to us like it is something that people use up or consume. Although it often appears that energy is used up, it has not gone away. Instead, it has been transferred to another part of the system or transformed into another type of energy. For example, when chemical energy stored in the foods we eat gets released, it enables or allows our bodies to perform the processes that allow us to survive and grow. When our chemical energy in wood is released by burning the wood, or it is transferred to the environment as thermal energy and light. Everyday energy use is really energy being transformed and transferred. Sometimes, when it seems as if the energy has disappeared, it has been transferred from one part of the system into another part. Following energy as it transfers and as it transforms shows us a chain of interactions. The chain for crude oil, for example, is illustrated below. Many vehicles and homes rely on the heat from burning products derived or made from this crude oil. Crude oil forms in the ground over millions of years as decayed or dead and dying plants and tiny animals get heated and put under pressure. The energy in the plants originally came from sunlight, from which the plants transformed into chemical energy through the process of photosynthesis. The thermal energy we feel as warmth from burning oil begins as energy from the sun that went through many transfers and transformations. So here is the chart to follow the energy. So the energy source is the sun, where we have light energy. The light energy is transferred or converted to chemical energy in plants. That chemical energy in plants is transformed into crude oil or chemical energy in the oil. The chemical energy is then burned and it is changed from chemical energy to thermal energy. It is changed from chemical energy to light energy. Crude oil is a source of gasoline and heating oil, was formed over millions of years deep inside the earth from decayed plants and animals. Crude oil contains chemical energy that was transferred to those plants and animals from other sources such as sunlight. So this is a picture of crude oil. You may need to pause the video now so that you can write down two main ideas from the first section, energy transfers and transformations. The next section is called the law of conservation of energy. Again, you want to make sure you write down at least two facts. You can always write down more. If you compare the amount of chemical potential energy of a liter of oil before it is burned in a furnace to the amount of thermal energy coming out of the furnace as the liter of oil burns, you will find that the amount of energy are different. There is less thermal energy released from burning the oil than there was chemical potential energy stored in the oil. What happened to the other energy? Was it lost? No, it was not lost. While some chemical energy in the oil is transformed into thermal energy when it is burning, some is transformed into other energy types that are easy to overlook if you don't consider the entire system. In the furnace, a small amount of the oil's chemical potential energy was transformed into light and sound, and some remained as chemical potential energy in the ashes. Sometimes the missing energy from the process is called lost energy. This lost energy has turned into another energy type that is either not useful or not recognized. In the case of heating your house, while sound and light may not be useful energy for warming you up, they must be considered part of the total energy released by the burning oil. The total amount of energy is the same before and after a transformation, also known as an energy conversion. Energy can be transferred or transformed, but cannot be lost, destroyed, or gained. This idea is known as the law of conservation of energy. This means that the total amount of energy before something happens must be equal to the amount afterward, regardless of the process or the energy types involved. The law of conservation of energy doesn't say which kind of energy must be present before and after an event, just that the total amount of energy doesn't change. So again, you want two ideas about the law of conservation of energy. The process of heating. Thermal energy is almost always released during the energy transformation. For example, a light bulb transforms electrical energy into light, but the system also releases thermal energy. A hot light bulb is evidence of this. When your body uses energy to move your muscles, your body also releases thermal energy. When you drive a nail into a block, the block becomes warm, indicating or showing that some of the mechanical energy hitting the nail was transformed into thermal energy. The process of heating, although useful in many situations and critical to life, is not always desirable. With the light bulb, for example, the desired energy type is light energy, not thermal energy. The thermal energy that is released during a transformation is not lost or destroyed, but instead spread out as it heats the larger system of the surrounding environment. Many transformations release thermal energy, but it can be a challenge to capture and use it. Even with the most efficient technology, only about 40% of thermal energy can be converted into useful mechanical energy. So the energy transformation of a light bulb. So here's our light bulb before. So we have electricity. So we have our light is plugged into the wall. So we're starting with it all being electrical, and that is being transferred, or I'm sorry, it's being transformed or converted into thermal energy and light energy. So this light bulb is 60% light and 40% thermal to get up to 100%. Energy efficiency. So we're looking for 2 more facts or more for the subject or the section of energy efficiency. No energy transformations results in 100% useful energy. People who are concerned with energy evaluate energy transformations by efficiency. Efficiency is the ratio of desired energy from an energy transfer or transformation to the total energy that went into the energy transfer or transformation. For example, a car's engine transforms chemical potential energy to gasoline into other types of energies. Only about 25% of the energy in the gasoline is transformed into the kinetic energy of motion. Most of the other 75% transfers to the environment as thermal energy and sound. Although no energy is created or destroyed, the engine's efficiency is only 25%. And since the car has to overcome air, road, and mechanical resistance like friction, it turns out that only a small percentage of the original chemical potential energy actually moves the car. Appliances and other devices are rated by the government for their energy efficiency. When a certain device is described as energy efficient, it usually means that it uses less energy than comparable models that produce the same results. For example, a newer refrigerator that has an Energy Star rating requires less energy to cool the same amount of food to the same temperature that a similar refrigerator without an Energy Star rating. By not needing as much energy to do the same task, the Energy Star appliance is more efficient than the one without the Energy Star rating. So using the same amount of energy, the more efficient it is, the less is transferred into undesired energies. So if we look here, this is what an energy guide for an energy efficiency model looks like. So less efficient is only 8, a more efficient or the most efficient is 10. And so this is at this is at a 10.7. So this one is more efficient. All right, energy conversion. Again, we're looking for at least 2 main ideas for this area. So I'm sorry, energy conservation. I said the wrong title. My apologies. So this is energy conservation. This is also known as the environmental science definition. So it's taking a look at what does conservation mean outside of a physical science classroom. An important idea related to efficiency is the idea of conservation. Energy conservation, not to be confused with the law of conservation of energy, means to reduce or save the total energy transformed in the first place. For example, someone who turns out the lights when not using them is conserving energy. Keeping a light bulb off when it is not in use reduces the amount of electrical energy needlessly transformed into light. Another way to conserve energy is to use an energy efficient device, such as a car that gets many miles per gallon or an Energy Star appliance. Using energy efficiently reduces the consumption or use of energy resources, reduces environmental pollutants, and reduces operating costs. For these reasons, learning how to transfer and transform energy more efficiently is a major goal of technology and engineering. So that is the whole article. And so that's the main part of the activity, is to read through and make sure you understand these different terms. We know that energy and matter, tracking changes of energy and matter into and out of and within systems helps scientists understand the system's possibilities and limitations. Many cause and effect relationships result from changes of energy and matter. So understanding how energy behaves will help you improve your home energy efficiency plans. And we want to make sure that you answer the analysis questions. You do have to make a drawing, and so then you're going to have to take a picture of your drawing and make sure you put it on the correct Google slide, and then continue to answer through the questions. So analysis question number 2, consider 2 different car engines, car engine A and B. So car engine A gives off 70% thermal energy. The question is, what is its maximum efficiency? Well, car engine B has a maximum efficiency of 25%. So that's just a fact. Energy A gives off 75% thermal energy. Engine B has a maximum efficiency of 25%. The question here is, which car probably gets better gas mileage? In other words, which car is more efficient, engine A or engine B? You do have to make sure that you figure out the efficiency of A before you answer. For question 3, it is an assessment question. So on question 3, I'm looking a little bit more closely at what you write to make sure that you understand this idea of the law of conservation of energy. So you're going to have to write more than a sentence. It says, your friend says that when someone drives a car, they use up energy. You need to develop an argument to refute or to go against your friend's claim using scientific evidence from this activity. In other words, you're using vocabulary. So you want to make sure you tell the difference or distinguish between the law of conservation of energy and energy conservation. Energy conservation. So in other words, that last section. So when it says develop an argument, that means that you're writing a paragraph. So you need to write several sentences to explain that when someone drives a car, they are in fact not using up energy. Okay? If you thought they were, you need to go back and reread the article. So then analysis question 4 is asking you to revisit that student sheet 1.2. All right, so we had taken a look at it during the first activity. You want to now go back and you're going to add more to this column. Right, so you should be able to add a little bit more to column 3 and column 4. The column 1, use in home, you need to describe. So window type, what kind of windows does the home have? Do you have single pane windows, double pane windows, 3-pane windows? What kind of windows do you have? Window treatments, do you have curtains? Do you have blackout curtains? Do you have no curtains? Do you have shades? Appliances, are any of your appliances Energy Star rated? Are they old? Are they new? How many do you have? What kind? What kind of heating system do you have? Do you have a heating system that is based on burning natural gas? Is it burning are you using electricity? Do you have air conditioners? Are they a central air system? Is it a window unit? Do you have a fan? So you're going to go through it and what kind of things are in your home or apartment. And then does it use a lot of energy, a little bit of energy, or a medium amount of energy? So this column, you're only answering with a 1, 2, or 3, or you can write a little, medium, and a lot. Column 3, you're looking at how are they transferring energy. So this goes with this idea of efficiency. Are your window types stopping the energy, the cold air from inside your house when you cool it, from getting outside into the hot air when it is summer? How efficient are your windows is here. A 3-ply window or 3 panes of glass is more efficient than 1 plane. So that's kind of how you're filling out this part. Then we have, again, our exit ticket and our question again. How can you use the law of conservation of energy to describe energy transformations? In other words, can you describe what's going on in this picture? Right? So what sentence or two are you writing to tell me about how a light bulb is changing energy, or how in general you are using the law of conservation of energy when you're going through an energy transformation or an energy conversion? And we have our new vocabulary words are in bold, and our returned vocabulary are not bolded. You can copy and paste these definitions as your book definitions for your vocabulary notebook. So we go through into the end. And then here again, we have the law of conservation of energy is the scientific law that states that energy can be transferred or transformed, but cannot be lost or destroyed. And I would add, or created. So that's a little bit about activity 5. So the reading and going through the different questions. Please make sure you have this all done before you come to the live class on Thursday. So if you have any questions, please come to office hours, and I will see you all soon. Have a great day. Bye-bye.